Hey everyone, and welcome back to the channel. I know I have not uploaded a video for the past 2 weeks, but in the morning I uploaded the one video in explanation of stack with the code implementation, and now I am uploading the video on queue. Okay, so but now I am back with another important topic, that is queue. Okay, so in this video we will cover what is a queue, then types of queue. That is, there are two types of queue. First one is a normal queue, and another one is a circular queue, and about the queue operation, that is enqueue, dequeue, front and rear, and then we will move toward the queue application in the real one, and then we are moving to the code implementation of that. Okay, so by the end of this lecture, or we can say video, you will have a clear understanding of how queue work, where they are used, and how to implement these them efficiently. So without wasting our time, let's get started. The first one is, that is the definition, that is what is a queue. A queue is a linear data structure that follow the FIFO, that is first in and first out principle. In stack there is a LIFO, that is last in first out. Okay, so make sure to understand this and don't confuse about the, it's like, remember, stack is basically first in, uh, last in first out, that is LIFO, and about queue it's basically FIFO, that is first in first out. Okay, so let's take an example of it. That is think of a queue at a ticket counter. The first person in the line get the ticket first, that is, in, or in other word, we first come first serve, first come first serve. Okay, like this. Okay, so person in line get the ticket first, and the new person join at the end of this. Like if someone is going, like coming to the that line and he want to buy the ticket, so he will at the end of the line. Okay, so the next is, that is the property of the queue. The first one, that is queue, in queue. Okay, it's basically insertion, that is, we have to insert the element at the rear. Okay, or in another word, we can say that it's basically two main operations. First one is a in queue, and the another one is dequeue. Okay, it's basically adding an element to the queue, and the second one is the removing an element for the from the front. Okay, and or it is of, that is dequeue is of two types. First one is a fixed, and another one is a dynamic size. And about the array, and array is of fixed size, make sure to remember that. And about the linked list, it's basically dynamic size, that is front and rear. So for linked list it's basically front and rear. And about array, it's basically fixed size. Okay, fixed size. So it's front means nothing but just the element to be removed, that is, element to be removed. And about the rear means the position where a new element is added. So basically adding, adding new elements. Okay, so the question is queue operation, we will explain, like we go to the theory and about the that four main operations as well. So about the things that we have to do is the code implementation, like how exactly it's working and all that stuff. So let's go to our code editor. I already write the code, so I will explain you the code. So it's basically, its defined size means nothing but just a maximum size of the queue. Okay, so that we have to define already. And about then we make a class of queue, and we declare the size front and rear, and in the yeah, in the public we just make a constructor to initialize queue. And after that we in queue operation, that is, we applied the first in queue operation, and after that we apply the dequeue operation. You can take a screenshot, and I will provide you the code in the comment section as well. And then we take a front element as well. Okay, and after that in the main we will make sure to all, like how exactly it's working. So let's run the code, and we get that is 10 enqueued, then 20 enqueued, and then 30 enqueued. So the front element is 10, so you can check this out. And then we remove the 10, and the front element is now 20 because we remove the 10, so the front element is 20. Okay, so issue is that, like, the problem it's we are facing in these, like in the normal dequeue. So let's go to the, yeah, we are taking this example, that is, we are implementing, that is, implemented all four main operations. Okay, that is, first one is a Enqueue, second one is a Dequeue, third one is a front, and the fourth one is a rear. Okay, I will provide you this code in the comment section. But the problem for with normal queue is that it's take a lot of space. That is, it is basically after multiple dequeue operation, the front index keep increasing. That is, front index keep increasing. Okay, it did not stop when our code is running successfully, and or in another word we can say that the leading to the memory waste. That is, leading to memory wastage. Okay, so for that the solution is circular dequeue. CIRCULAR, circular queue. Okay, so it's basically it did not waste your memory location storage as well. So that's why we use the dequeue, circular queue. So let's check the code. So yeah, just a second, go to our editor. So yeah, I will provide you this code, so make sure to comment it out. And here as well. So this is the comment, and just remove this one. Okay, so this is the next code of this. So just a second. Yeah, so what we get is, okay, okay, so in this code we will do just a second. Yeah, again we have to declare the, where is it? Yeah, again we maximize the size of queue, then we initialize the queue. Here we initialize queue. Okay, and then we in queue operation, it's here we just initialize queue, and about this we first apply in queue operation, and or we can say, yeah, in queue operation and other step, and then we apply the condition, that is if condition, if insertion first element is set from to 0. Okay, and then about the this, where it is, just a second. Yeah, about this, it's mean nothing but the move real circularly. Okay, and then we write the atom value, and then we apply the dequeue operation. Okay, you can take a screenshot and practice to it as well, because I want to explain you it this in a very short interval of time. Okay, and then after we write the cout, and then for this if condition, that is front equals to real, means nothing but if only one element was left. Okay, and then we just decrease the size, that is front equals to -1, and basically we take it in a reverse format. And then about this else condition means nothing but from move front circularly. Okay, and then after that we just implement the code in the main function. Okay, it's basically the enqueue operation move the rear in a circular way using modular percentage operator, and about the dequeue operation means the move the front in a circular way. If the front equals to real, that means that only one element was left, so we reset both the front and rear to -1. So let's run the code, and we get that is 10 enqueued, then 20 enqueued, and then again 10 dequeued. Okay, so the question is why we use dequeue. So yeah, where it is, yeah, so we already take this example as well. Okay, so the question arises why we use this. So let's go. It's basically first one is a efficient space utilization, and the second one is a use in the real world application. It's basically no unused. That is, if you require something like 20 MB, so it's take only 20 MB, not and not more than that. Like unlike a normal queue take all the memory that you have. And about the real world application for this, it's like basically it's like OS scheduling, then circular buffering, and then stream services like that. So the real world application of queue is basically in job scheduling, and then print queue, then customer support system, and then circular buffer in the system. So the what is mean by job scheduling? It is basically round robin CPU scheduling uses queue to manage multiple tasks. And about the print queue, it's nothing but just when multiple documents are sent to a printer, it processes them one by one, and not all are in one. And about the customer support system, it's basically call in a customer service center as answer in FIFO, that is first out. And about the last one, that is circular buffer in streaming, it is basically you can take an example of YouTube, Netflix, which circular queue for buffering video streaming. Okay, so the summary of this lecture is, so just a second, yeah, so we just take a queue follow FIFO, that is first in first out. Then operation include Enqueue, Dequeue, front and rear. And about the circular queue prevents space wastage. That's why it is basically save your memory, data and wastage of that. And about the queues are widely used in job scheduling, printer, customer support and buffering. So if you found this video and lecture is useful, so make sure to like, share and subscribe. And would you like to more practice problem in the next video? So let me know in the comment section.